Hey everyone, and welcome. Today, we are diving deep into something that's basically the invisible engine of the modern internet, the REST API. It's the secret sauce, the magic behind how all your favorite apps talk to each other. So, let's get into how it all works.
Have you ever just stopped and wondered how your phone can show you the weather forecast, let you order a pizza, and let you scroll through your social feed all at pretty much the same time? Each one of those apps is talking to a totally different service somewhere out there on the internet. How do they all communicate so smoothly without it turning into a total mess? That's the big question we're going to answer today.
Well, the answer lies in something called an API. You can think of it as the web's invisible messenger service, constantly shuttling requests and data back and forth completely behind the scenes.
Okay, so what is an API? The fancy term is Application Programming Interface, but really it's just a contract. It's a clear set of rules for how one piece of software can ask for things from another. Now, while there are a bunch of different types of APIs out there, one particular style has become so dominant that when most developers just say API, what they really mean is a REST API.
To really get what's going on, let's forget about code for a second. The absolute best way to understand this whole thing is with a simple analogy. Just think about interacting with the web like you're going out to eat at a restaurant.
So in this scenario, you're sitting at the table. You are the client. The kitchen, the place with all the ingredients and the chefs that actually make the food, that's the server. Now, you can't just walk into the kitchen yourself and start cooking, right? You need an intermediary, and that's where our API comes in. The API is the waiter.
The whole process is actually pretty straightforward. First, you, the client, make a request by ordering something off the menu. The waiter, our API, takes that order and carries it back to the kitchen. The kitchen, the server, gets to work and prepares your meal. And finally, the waiter brings the food back to your table. That plate of food is the response. And that's it. That is the fundamental request and response cycle that powers almost the entire web.
So what makes this a REST API? Well, REST stands for Representational State Transfer. I know, it's a mouthful, but all that fancy phrase really means is that the server sends you a representation of the thing you asked for, like a photo, a chunk of text, or some user data. The best way to think about it is that REST is the universal training manual for every single waiter on the internet. It's a set of principles that make sure they all behave in a predictable, standardized way so the whole system just works.
All right, for this system to work, the client, that's you, needs to speak a language that the API, our waiter, can understand. So let's break down what an actual request looks like.
Every single request starts with a URL, which in the API world we call an endpoint. It's basically the restaurant's address. If we look at this example here, /v1/users/54, we're being super specific. We're telling the server we want to talk to version 1 of its API, we want to look inside the user's collection, and we want the one specific user who has an ID of 54. That single specific user is what we call a resource.
But, just having the address isn't enough. We need to tell the server what we want to do with that resource. And for that, we use what are called HTTP methods, or verbs. A GET request is just for reading data. It's like asking, hey, can I see the menu? POST creates a totally new resource, like adding a brand new item to your order. PUT replaces an entire resource. Delete is, well, you can guess that one, it cancels the order. And patch is for making a small change, like saying, you know what, just add extra cheese.
Now, the difference between put and patch can be a little tricky, but it is absolutely crucial. A put request replaces the entire order. So if your original order was a burger and fries, and you send a put request for just a soda, you will end up with only a soda. The burger and fries are gone. A patch request, on the other hand, just updates a piece of it. It says keep the burger and fries, but just add a soda to the order. See the difference?
Once the server processes your request, it sends back a response, and that includes a status code. This is like the waiter giving you feedback. A code in the 200s means success, order up, everything went perfectly. A 400-level code means you, the client, made a mistake. A 404 not found is like trying to order something that's not even on the menu. But a 500-level code, that means the server messed up, the kitchen is on fire, something went wrong on their end.
So why? Why did this particular set of rules, this whole REST architecture, become the standard for building APIs? Well, it really comes down to a few powerful guiding principles.
As Amazon's CTO, Werner Vogels, famously said, APIs are forever. And he's right. Once you release an API out into the world, people build entire businesses on top of it. You have a long-term commitment to keep that thing stable and reliable. And the principles of REST are designed to do exactly that.
This stability comes from a few core ideas. First, client-server separation. The client and the server are completely independent. This means you can change one without breaking the other. Second, statelessness. The server doesn't remember anything about your past requests. Every request is a completely fresh start, which makes the system incredibly simple and way easier to scale up. And finally, a uniform interface. By using these standard HTTP verbs and URLs, you kinda automatically know how to order from any REST API, just like you know the basic process of ordering in any restaurant you walk into.
But what happens when the business has to evolve? What if the restaurant needs to update its menu?
This is a huge challenge. If you suddenly change your API, you could break every single application that depends on it. You just can't change the menu on your loyal customers overnight without any warning. So how do you manage that kind of change gracefully?
The answer is versioning, and a really common standard for this is called semantic versioning. It uses that three-part number you've probably seen around: major, minor, patch. A patch release is for a tiny bug fix. A minor release adds new features, but doesn't break any of the old ones. But a major version change, like going from V1 to V2, that's a big deal. It signals a breaking change. It tells developers, hey, we've changed the menu and you're going to need to update your order.
Developers can then request a specific version of that menu. Probably the most common way is to just put the version number right in the URL path, like you see here with /v1/users. Another popular way is to include the version you want in an HTTP header that goes along with the request. Both of these methods just let the client and the server agree on which version of the rules they're going to play by.
You know, REST has dominated web communication for over 2 decades now, and for very good reason. Its principles are just that powerful. But as our digital world gets more and more complex, we have to ask, is REST the final word, or is it just the first chapter in a much longer story of how our software will learn to talk to each other? Well, that's all for this explainer. Thanks for joining us.